Okay, let's jump into this. You've brought us some interesting source material today.
That's right. It's an excerpt, specifically looking at understanding rainfall through simulation.
Simulation.
Okay.
And our mission for this deep dive.
Well, it's to quickly unpack that source, pull out the key concepts.
Give you, the listener, that shortcut to getting what this is all about.
Exactly. It's about using simulation for rainfall, particularly thinking about irrigation planning.
Right, irrigation planning. So, cutting straight to it then, the source mentions a specific tool they use.
Integration. Yeah.
Integration. Okay. Sounds a bit technical, maybe.
It is a mathematical concept, yeah, from
Yeah.
calculus. But the source points to its practical use here,
Which is?
to compute the total rainfall. That's the job it does.
Okay. Total rainfall. And why integration? I mean, how does that relate to rain?
Well, think about rain, right? It doesn't usually fall all at once. It falls at a certain rate.
Mm-hmm. Like inches per hour or something.
Yeah. Exactly. Or you could think about intensity over an area. Integration is basically the math that adds up all those tiny little bits.
Ah, okay. So adding up the rate over the whole time it rained.
Precisely. Or across the whole field area, it sums it all up to give you the total volume of water.
Got it. So you go from rate to total amount. Makes sense.
And once you have that total amount, that precise figure for accumulated rainfall, what then?
Right. What do you do with that number?
According to the source, you use that calculated total to simulate its effect,
Yeah.
specifically for irrigation planning.
Simulate the effect. Okay, so you measure the rain, get the total, then simulate. Why the simulation part? Why not just use the total?
That's a good question. Because just knowing, say, 1 inch of rain fell doesn't tell the whole story for a farmer, right?
What else do you need?
You need to know how that 1 inch actually impacts things. The simulation lets you model that.
Like how much soaked into the ground.
Exactly. How soil moisture changes, maybe how much ran off, basically how much usable water the crops actually got from that rain.
Ah, okay. So it translates the total rainfall into its practical effect on the field.
Precisely. And that allows for much smarter irrigation.
Because you know how much the rain actually helped.
Absolutely. You're not just guessing based on the raw rainfall number. The simulation, using that accurate total, helps you decide exactly how much extra water is needed, if any.
And when to apply it.
Right. So you could save water, save costs, maybe even get healthier crops because they're getting just the right amount. It's about optimizing.
Moving from, like, rough estimates to something more data-driven.
That's the idea. And the source adds one more piece of context here.
Oh, yeah.
It mentions this whole process, integration for totals, simulation for planning, in the context of something called DeepSeek.
DeepSeek. Okay, does it say what DeepSeek is?
Not in detail, unfortunately. It's mentioned, but not really defined in the excerpt we have.
So it could be.
Yeah.
A project name? Software?
Could be. A research initiative, a specific platform they're using for this kind of agricultural analysis, maybe even some kind of sensor system we don't quite know from this piece.
But its inclusion is interesting. It suggests this isn't just theory.
Exactly. It ties the method, this integration simulation approach, to a real-world application or system.
Grounds it a bit.
Yeah,
Shows it's being used or developed somewhere specific.
right. It signals that this analytical way of looking at rainfall is part of, well, something bigger.
Okay, so let's quickly recap for you. The core idea from the source. Using integration, that math tool, to get a really precise measure of total rainfall.
Then taking that data and feeding it into simulations.
To really understand the rain's effect on the ground, helping make irrigation planning much smarter, more efficient.
And all this is mentioned alongside the name DeepSeek, suggesting a specific context or application.
It's essentially applying some pretty advanced tools to understand and manage a basic natural process better.
Getting more control, more optimization.
Yeah. Which leads us nicely into a final thought for you to maybe mull over after this deep dive.
Okay.
If we can use tools like integration and simulation to fundamentally change how we manage something like water for agriculture?
Again, getting really precise about it.
Right. How else could applying these kinds of advanced analytical or mathematical approaches revolutionize the way we manage other natural resources? Or maybe other complex natural processes?
Where else could that kind of precision make a big difference?
Exactly. What else are we currently managing with less precision that could be optimized or understood far better using these kinds of tools?
That's definitely something worth pondering.